Okay, hello guys. I hope all of you can hear me till the very end. Today we learn about a new technology called vision language models or multimodal LLMs and how they can be used in mobile development. I'll start with a 20-second video of we playing Angry Birds with this technology. We have given it the objective to, identify certain enemies, and then there is a bird that we can use to kind of achieve the objective. So there's a fair bit of training involved, but right. So this one was done by a model. We'll get into the details of this prompt, but we'll eventually get into that. But this is to just tell you the capabilities of VLMs and how they can take over, mobile app testing. So to get into the presentation, the topic of the presentation is, how do VLMs go into mobile development? But we start with, talking about why app testing is the first place to start with. Why it's a good entry point, because organizations are, still building this trust with AI, and then testing could be one place where it could be a good entry point. Then we talk about specific testing challenges that VLMs can solve better than the current state of the art. And then we talk about how companies have measured, ROI on this thing, right? We also talk about, the future of moving from experimental to essential. So why testing first? Everybody knows this is one of the boring slides of the whole presentation, that it's one of the biggest development bottlenecks. And a developer spends 1/5 of their time of the sprint just testing what they have built. It's also a universal pain point, which means that everything, including the automotive standing outside, we were having a chat with Herman and folks and the other automotive folks, that they also have an infotainment system that needs testing. It's a lot of manual and how to get about that. Then there is the low risk, which I already talked about. Instead of playing with VLMs in production with users, it's much better to build that confidence with testing space. For the leadership folks in here, the question that they should ask is how much developer time can be reclaimed, what can be the cost savings. For the developers in here, they should think about what interesting model training stuff they can do instead of recovering brittle testing scripts. And then beyond testing, how the flywheel can be created, right? Can we go into app prototyping for the product managers in here? Can we do app prototyping using vision language models? That's another thought that you guys should leave this, chat with. Why it matters? So why user-centric testing first is because we come with this hypothesis that what matters to businesses is what is the experience of their users. And it's not about testing network separately, UI separately, unit tests separately, and bridging it all up. So did I build a product that actually delivers value to my users is the big important questions that all of us in here ask ourselves. Then going into what unit tests do is basically, did I implement this specific function right, which is okay, which is very much needed, but it misses the bigger picture. So here are we solving end-to-end tests first, right? Current state of the art, as there might be people who are new to this, I'll talk about what is the problem with current state of the art. It's Locator-based, and there are frameworks which use identifiers to map every element on the UI to a certain tag, and then they keep on using it. As the company grows, this code base grows, and it's difficult to keep these identifiers updated. So it leads to this maintenance burden and visual blindness. So what I mean by visual blindness is, let's say two fields are overlapping each other. Their identifiers are very much correctly populated, but when you give it to the user, you figure out that these two fields were actually overlapping, and it was not caught by your test. So that's the visual blindness in current framework. They do not actually see the screen as it appears to your users. There's skills required, as in you need to be a developer to contribute to automation. Setting up automation require weeks and months sometimes, depending on your organization size. So there's a skill gap where product managers or people who code a little less, they don't know how to really contribute to automation. This is another thing we're trying to bridge. And then the main goal is achieving higher velocity, like a weekly or bi-weekly releases of sprints, right? So keep releasing at a very fast pace. The flakiness problem is here. On the left, you'd see a selector-based framework, which talks about how the element identifiers are used. And then you can see that the first problem is either you are relying on a class name or you are relying on a text, which can change, which as the different languages come in. For example, we have folks who are solving, languages in languages space. Tolgi is here, right? So there is a problem of relying on text only. There's a problem of relying on classes. There's a problem of relying on element identifiers, XPaths, because if you move the element slightly here and there, the XPath would change, and you'd be, caught with this updates. So timing issues are there. You have to figure out how things are loading, if the screen is loading, not loading, those kinds of things. And basically, that's the problem. So it's, if I'm correct, your pipelines, CI/CD pipelines would be 30%, facing this problem, breaking again and again, somebody going to repair them, or you release without even fixing it, right? Now, once this context is set, there is this maintenance burden, like a new feature was added, or a UI redesign happened, or a component refactor was done. Either your layout has changed, your ID has changed, and that has led to updating of selectors, updating of 10 plus test files, etc. Right? So same point. Visual blindness, as we talked about, you might be able to verify that there is a certain profile element there, but you don't know whether the icon shows up as it is, right? So that's the problem with the current frameworks. And like text overlapping, image not loading, all of these will not be caught by your selector-based frameworks until you really write for it. Now, where the VLMs come in is they help you understand this. They are context aware and they can work with natural language. So we'll go into details on this slide. The components that really make a vision language model. Anybody who has used VLMs before? Just so that I can. Okay, fair, good. So then, I'll keep it simple for this slide. There is one part of the model which is which is responsible for dealing with images. So basically, if you imagine a screenshot that gets broken down into patches of screen. So let's say you have a certain X by Y size of your mobile, and then it will get broken down into, let's say, 16 by 16 sized patches, which would be fed to this encoder piece. And this encoder would make sense of what elements are there on this in the 16 by 16 pitch, what is the position of it, what is the color, what is the text, and spatially how it is related to other stuff. Then there is this text encoder, which is responsible for understanding the natural language instruction or whatever you are trying to get out of that screenshot. It may be a question and answer. You might be asking it that whether there is a login button on this page, or you might be asking whether there is, why is it not working? So converting that text into embeddings is the responsibility of the text encoder. Then there is a feature fusion, which is basically responsible to getting this. The multimodality is basically feature fusion, where it takes what it understood from the image, what it understood from the text, combines it, and tries to answer your question. Element detection is where if you ask a pinpointed question, like, can you give me a position on the screen where this specific element is? That is element detection. And today's models, by the way, are 40% accurate about XY coordinates, right? Action planning is basically what do I need to do to move to the next screen? So you can ask it that, hey, my user is trying to do this. Where do I need to tap? Or what do I need to do to get to the next screen? So it will say, okay, go and type tap, go and tap this, and then start typing because your field is probably in focus or something. So it can help you with action planning, and then visual feedback, which is basically, is everything in place as per the next transition that happened on the screen. Going to a specific example, let's say, imagine a screen which has this login button not working because there are two text fields, username and password, which are not filled, and somebody is continuously trying to tap this field and it's not working. So if there's a question and answer on why isn't the login field not working, the encoding stage would split the screenshot. It would have, each patch would have a certain dimension. So let's assume a 1024 sized dimension vector, and then it would take care of the positionings. As I mentioned, that will tell you that this button appears on lower half of the screen, and these are the visual characteristics of it. This is the text, this is the position, and then any text related to it. Right. So now the multimodal fusion is where you have asked the question, and in the question it tries to figure out, let's say, because you have asked why isn't the login button working, it says that login. So you're specifically looking for a logging button. So the multimodal attention. So there are two types of attention here. One is the cross-modal, and one is the self-attention. So self-attention tells every element that what to focus on and what is its relationship with everything else in the image. cross-modal is basically taking what the text wants you to focus on. So here it's a login button, and it will try to find the login button on your screen with the help of the image encoder's work. And once it has found it, then it goes into deeper part of the question, which is working, why isn't? So working is basically functionality, and why isn't is the reason, is the answer that you're looking for. So once the model has understood this, it looks for again, the self-attention that it had. Using that, it tries to go into your image and see that, okay, looks like the two fields that are here are not populated. And there's an error message that says that you need to populate it. And that's why it's probably not working. So it will reason with it based on the training that has been done. And basically then come with a response saying the login button is disabled because required fields haven't been filled correctly. The username field is empty, and the error message below the password field, right? So it's token by token generated that way for you. And there are different kinds of model as well, clip, BERT, depending on how do they pay attention, et cetera, et cetera. Like I can get into details of it later on, but for the interest of time, we'll move with the next one. So the VLMs basically now have freed you from the selector hell, which is basically something that you were writing as an identifier. Now you can simply say click the login button, and it doesn't really care about your locator, right? So this is the breakthrough thing that we have been seeing, and there are pieces that we need to fix still, which I'll talk about in the next slides. Cool. So it takes care of relative positioning, which is adaptive, where you can say that there is a top right icon somewhere. Please go and figure out whether it's this profile icon or not, etc. So positionally, it's very simple to reference a model and ask it whether something is there or not. So we call it adaptive positioning, etc. There's a video of it. We'll quickly get to it. Then UI resilience changes. Basically now the left-hand side shows the traditional mechanism, and now you are, and the right-hand side is the vision-based. Now you are good with like button ID changes, layout changes, text changes, and even a new icon being introduced. So we were talking at a booth with one of the clients, and they mentioned that they keep adding these new experiences, gestures, icons. What can VLMs do is they can explore it themselves. So for example, let's say there is a flash icon newly added that leads you to a paywall subscription buying. In the exploratory phase, the model can tap it and figure out that, okay, these set of screens opened, looks like this icon stands for buying a subscription. So you can even go into the territory of generating test cases from there. So different screen sizes are also taken care of, because once we train the model, it's based on what was the dimension of your images, what was the DPI, etc. Right. The art of VLM prompting. Now what we see is there's a system prompts, and there are structured prompts that you need to give into the system. Why they matter is because most of the folks here who are into prompt engineering, they would be facing this problem that prompts are becoming larger and larger, difficult to manage, difficult to keep the version track of. This is for the people who don't know about lot about prompts. This is a basic structure of them. There is a system context where you give it a role that you are a certain software engineer or a testing engineer. Then you tell it this is the visual input to it, that you're working with these screenshots, and maybe if it's annotated, even better, because then you are helping the model understand the boundaries of elements. Then there is task description, that what the user wants you to do, and then is a structured output format. Structured format was launched by OpenAI and the other folks eventually once they saw that models were not doing great with responding first, but now it's pretty much sorted. This is what a basic prompt looks like. Now, so basic prompts, like if you just find the login button and tap it. Sometimes it can be too vague or it can be ambiguous. Let's say a food delivery app, you have 4 dishes and each of them has an add button. If you just tap on add, the model will get confused which ad you're talking about. So while you're designing prompts, take care of ambiguity, take care of mentioning when the task may be undoable. So the model tries its best to do the action. So you should tell it that when an action is not doable. So you should tell it that if you do not find this certain item here, do not try to tap a random element and go into the next. That's where the rules come in. So your prompt structure now looks like, here's what the user is trying to do, here is the screenshot, here are the rules that you should not play with elements that are not there, and think of them as moving you to the next level. And this is the structure format that I want out of you. So this is how one prompt looks like. There can be command-specific prompts. So now if you're solving this testing problem, the way we are solving it at in our use cases is we have a separate prompt for tap, for type, for scrolling, and there are versions of that also. So when you implement this, you have to take care of how you're structuring your agents. It's not like one agent can be capable of doing tap, type, text, etc. We think of more it like leaf nodes, where one agent is capable of tapping, typing, scrolling, dragging, etc. So you have a command-specific template, and there's some examples of it on this screen. Context is key. We know this, that the more context, the better context you provide, it's better. Not the more, but the better one. As in, give it the context of the test you are trying to run. The way we run it is like we have the whole statements. We don't try to write one line intention and convert it into plan. Planning is very difficult because it's a partially observable Markovian process. A mobile, only one screen is visible at a time. So you don't really know what's going to happen next. So that's why it's important to not give it just one line of prompt, go line by line and make that process easy. Clarity and specifications is where you tell about error scenarios, which you already talked about, structured output. Then JPy is a new finding that we had. It's a great research paper that's out there, and everybody here should probably read this if they find time. Take a screenshot of this. What it tells is genetic evolution. What it works with is genetic and Pareto principles, where it says that we will try to let the LLM figure out the right prompt itself. So imagine humans not even just having little nudge into how to write a prompt, because there's so much, hundreds of screenshots they are dealing with, and how do they really figure out the right prompt, right? Sometimes they change something and the other case starts to fail. So JPy is exactly to solve that, and is an example of this. So reflective learning, as in using the LLM itself. Then genetic evolution is basically keeping multiple prompts for a certain action like tap. It will have 4 to 5 variants. And then, analyzing based on there's a validation set and there's a test set. And I'll show you the example of this. So think of this as one situation where I think this one is a better example. It has the structure, the architecture of JPy is this way. It has a screen analyzer module, which talks about how to analyze screenshots, decide next. There's action planner, there's a screen planner, there's a test report module, and validation. So you feed it a screenshot, and then you feed it the action the user is trying to do. It comes up with a response, and it says that, okay, let's, for example, say that the keyboard pop-up was open and the user was not able to take a certain action. So with that input, when the feedback came in and the app crash logs came in, it was able to tell that certain keyboard was open and that's why I was not able to take an action, and it takes it into consideration, improves its prompt, says that check if soft keyboard is visible, if keyboard appears, scroll or dismiss the keyboard, wait for animations, and this is the whole prompt generated by the model itself. So model it's better than reinforcement learning. It is learning from the examples where it failed and improving itself. Just the catch is that there can be three different variants, as specified here, that there is a prompt that excels at form filling, there is one that is good at navigation, and one at validation. And the rest of it is basically discovery. As better the data you feed, the better it gets at evolving itself. So we have had good results adapting it, and the company is called Driz. We have a small video of it, which just explains how we kind of operate. So this is a multi-app situation, which we've done for one of the US clients. What's happening here is it's as simple as writing. So it's as simple as writing. This is a web app right now. On the left, you have the editor, where you can simply, anybody, even a non-technical person or some subject matter expertise, can write in simple English what they want or how the navigation should go. And we use the VLM, the trained VLM that we have on top of like models like Qwen or UI Venus or TARS, etc., and then execute it on the mobile or a real device, which is there streaming on the right. So tap on so it presses an amount, sends an email, switches the app. So clients have a switching the app use case where they have to switch between apps and validate stuff. There can be 3 or 4 apps for a restaurant partner. So it types in the email and switches the app shortly. And then once it has switched the app, now you can see that it can validate stuff there as well. It can go into the emails, do stuff, etc. We have also built modules where you don't need to do stuff like login again and again. You can save it as a script, and it will run every time you point to it. Right? So that's a module video here. And then there is an interesting question around how to get repeatability, right? So engineers want repeatability with AI. That's where we have built caching, which is basically able to remember the perceptual, the perceptual characteristics of, let me open that video. I think. So I'll maybe talk about it. I don't have it open, I guess. Yeah, this is the one, correct. So if you see now, if the model was taking 5 to 7 seconds before, now it has reduced to 2 seconds because we are able to remember that certain item was in the certain place of the screen, and now we have reduced it to a computer vision problem. Now you need to do is find an element within another image and remember the physical characteristics of it. For example, booking.com, if they have 3, 4 radio buttons and they have text associated with it, when you're executing it for the first time, it may be breakfast is above twin sharing room, and the next time you execute it, the order has changed. These kind of funny things happen where the cache should not work because if you use a selector-based cache, then it would have picked up the wrong radio button. But if you have the VLM-based or a vision-based cache, then it is smart enough about the context and using the right radio button and going forward from there. There have been places where all of this has also failed, which I had in a document. And this is where we have messed up. For example, check this out, where we had this store action, right? So we have a store action which lets people store anything from an API call or from a user screen and have end-to-end feel, right? They can do test seeding by API calling. They can do they can basically do deletion of test data, and then they can store stuff. So the user is trying to store the slot of delivery. The selected one is 2 to 4 p.m., but it selected 4 to 6 p.m. because it was not clear that what is selected, what is not, right? It looks like the gray one means selection, but actually it's the blue. So these kind of funny things happen. Another one is swiping the section. We get sometimes wrong where the instruction that the user wrote was swipe left in the tab section below the search bar until you reach the kids tab. So it found that specific, it felt like that this is the place where I need to swipe and everything would swipe on its own, but that was not the case. It had to be a little above, right? So model gets confused sometimes, and then that's where the prompts or the English that you're writing matters, and it gets you better and better. We do have a CI/CD integration where people can tell that So we keep the scripts in GitHub, and every time you release an app, the same GitHub scripts would be picked, run for your release, and you will get results in form of an API response or a report or a Slack, whatever you want, and that keeps your CI/CD fulfilled. There's a lot to talk about. We have a booth, but I can take some questions if I'm not over time, and make it a little more interactive. Okay. Thanks, guys.